Last week on Wednesday, October the 12th, at around 9:50 AM Japan Standard Time, the Epsilon-6 rocket was ordered to self-destruct after a problem related to attitude control. This Tuesday, JAXA published the first investigation reports. They've been able to pinpoint the failure to a single system, though the exact failure mode is still being investigated. Hi, I'm Ayakuni, and today I want to talk about the Epsilon-6 launch failure. Before we get into the exact failure, I want to describe how the rocket is supposed to fly. The second stage of the Epsilon rocket is controlled by means of thrust vectoring and an RCS system. While it's burning, the RCS system is only responsible for roll control. The third stage, however, doesn't have any kind of guidance. Instead, the second stage orients the third stage such that they can be spin stabilized. Stage separation and engine ignition happen after the rocket is spun up, and the orientation is verified to be as designed. This didn't happen as the telemetry showed that the orientation of the rocket was off by 21 degrees. Because of this, the decision was made to have the rocket self-destruct. So why did the attitude control system fail? The second stage of the rocket has two sets of RCS thrusters, Y+ and Y-. As it turns out, the Y+ RCS thrusters never actually fired. To explain why, let's go into how the RCS system works. Each set of RCS thrusters has a pressurized hydrazine tank. Around stage separation for the second stage, a pyro valve is opened. This is a valve that can be opened with pyrotechnics. In order to ensure that it opens, there are two igniters on each pyro valve, controlled by two switches for redundancy. Switch A firing a second before switch B to ensure they don't overlap. When switch A fired, the pressure inside the Y- thrusters immediately increased to the pressure inside the tank. This pressure increase was never seen for the Y+ thrusters, and JAXA engineers have identified three possible explanations. A. The signal from switch A was sent, but due to a problem with cables or connectors, it never arrived, and switch B malfunctioned or had the same issue. B. The signal arrived, but somehow the ignition of the pyro valve failed. Or C. The pyro valve fired, but the pipes were somehow completely obstructed. As the state of the valve wasn't measured, this is as far as the telemetry-based investigation can go. Investigations will continue until they know exactly what the problem was. When I initially heard there was a problem, I'd hoped it was related to the spin stabilization, or another third stage specific problem. The next Epsilon rocket launch will be of the Epsilon-S variety, which uses a brand new third stage with thrust vectoring instead of spin stabilization. Sadly, it seems like this is a problem that has the potential to even ground the Epsilon-S for a while if they decide they need more time to design a fix. Nevertheless, I'm looking forward to the next launch. Space is hard, but I'm certain they can make it work. Whenever the Epsilon-S launch will be, I will be here on this channel to cover the launch, so subscribe to catch it when it happens, and until then, I'll see you next time. Bye! Such a shame. I think I don't want to make a video about like the payload. One of the CubeSats, they were going to use a thrustless propulsion method that would make use of the Earth's magnetic field. It was really quite interesting. Oh well, maybe next time.